We must understand what the question is all about. Assuming the spring was of this shape initially, there is a length, the original length of the spring. By the time it was loaded with a mass of 30 grams, definitely it will be stretched down. This is the 20 gram mass. So there will be an extension represented by E1. We don't know the extension, the size of the extension E1. We are told again that the load was increased to 30. But we know very well that increase in the load will result to an increased extension. So by the time we add a load of 30 grams, the wire will be drawn down the more. This is load 30 grams. So the extension, if we remove the initial length, the extension this time is E2, while the upper side represents the initial length of that spring. We can get the extension produced because we are told that the total length from here to here, we are told, is 14 cm. And we are told that the length of the spring when the load is 30 grams is also 16 cm. Here is the initial length or the original length of the spring. With this information, we can get the extension. We know that the initial length plus extension 1 for the first case is 14 cm. Therefore, extension 1 is 14 minus L. Question number 1. That is when the load is 20 grams. When the load is 30 grams, we now have load plus the original length plus extension 2 will give us 16 cm. This implies that the extension 2 is 16 minus the initial length. This will serve as our equation 2. Now, since we are told that the spring obeyed Hooke's law of elasticity, we have what we call Hooke's law equation. For a spring that obeyed Hooke's law, we have that the mass M1 over the extension E1 equals to the mass M2 that